How's it going, everybody? Welcome back to Make It and Break It. My name's Andrew, and today beside me is my Yamaha R6. This is Project HyperTenere. We currently still have an engineless 300C behind me because it's the hardest thing in the world to sell something that you legally own but that no one wants to make money on. I don't know. It's so weird to try and sell a salvage car that has not been retitled in Washington. It's a very weird experience. Anyway, we don't have enough space to work on the RX-8, so I'm getting sick of working on the garage, so we're going to start working on our Project HyperTenere. So we're sitting here because we're actually going to start working on our foot controls. So this is a Yamaha R6. It's a sport bike, which means it has rear sets. Your feet are to the rear of the bike, basically to the rear of your seating position. It crunches you up, gets you up higher, gets you more ground clearance. But it makes it really hard to stand up, especially if you're huge like I am. Also, it has essentially sport pedals. So they're not really designed to have large boots on them, nor are they designed to have large boots actuate any of your foot controls. So we need to redesign pretty much all of those to make it, let's say, comfortable to operate in adventure boots and motocross boots. Which means we've got to CAD it up and start using our 3D printers for what they really belong doing, and that is prototyping and building functional parts. So that's what we're going to kind of do today. So first things first, we're going to disassemble the right side rear set from my Yamaha R6. We're going to take it back into my office, take some measurements, CAD up a fitting tool, print one of those, and bring it back out here and see what sort of fit we want on our pieces. And there we have it. This is a brake side rear set for our Yamaha R6. So let's go take this inside, take some measurements on it, and show you what we're getting for a fitting tool. Okay, so it's a little bit later. So this is our fitting tool, and it's essentially two pieces. So it's a piece that we measured based on the removed rear set, so that we have hole here, and then a series of holes here to check fit a stand-in foot peg here into these holes. This is hard. There we go. So we could move around and wear it. We could put our feet on here and test fit and see what felt best. So where this thing is sitting right now is approximately where the stock foot location is. So it's up and back. It's over. It lets you clear your exhaust. It keeps as much ground clearance as possible. It's a good foot location for a sport bike, which is why the sport bike is so very good and can turn and all that sort of stuff. But it's basically impossible to get a fully off-road geared person into a riding position, especially with this seat the way it is, the way it shoves you into a certain riding position. So we spent a little time moving this thing around here, and kind of as I suspected, all the way down here was about the best fit. It gave us the most leg room, while also eventually, because this is not necessarily perfectly representative of where this foot peg's gonna sit, so the peg's gonna sit another like 2 inches clear this way. So it lets us clear the exhaust as much as possible, lets us clear the engine as much as possible. Hello, Joseph. How's it going? You doing good? Yeah? Welcome to the internet, Joseph. But it also lets us clear the front engine case as much as possible and keep as much space between our feet and the engine as we can, because while I don't think this fairing will stay on here, we do not want to have our feet like resting on the engine case, because that's also a good way to melt your boots. So in this case, these holes are spaced on 1 inch spacing. So, you know, regular, this is standard here. So what we're doing is we're spacing our feet 1, 2, 3, 4 inches forward and 3 inches down from the stock foot location. So that's where we found our optimal foot location to be. So next is to actually go in and design a prototype. We're just going to call this a 3-point prototype because it's not necessarily designed to mount your brake cylinders or anything like that yet. But next part of your process should be to go design your major 3 locations, then you can add your accessories on afterwards. So we're going to go do that. But we're going to go do that for both sides. So we've actually pulled both rear sets off. Let me go grab those for a second. So right down here we have both of our rear sets. This is our right side rear set. That goes that side of the motorcycle where the fitment tool is. And this is our left side rear set. And this has your gear shift connection here. That runs up to your transmission. And we're going to go try and sketch foot pegs for both of these so we can check the fit on both sides, not just one, now that we have a rough idea of where we want to take it. And that means we need to actually measure both sides. Unfortunately, this hole spacing here and here and here and here is not the same on either side. This is a little bit tighter of a V. This angle in here is tighter than this one. So we're going to have to measure both sides in order to get good locations for everything here. And we're going to do that via a measurement plan I've got up on my whiteboard here. So essentially the idea here is to try and locate the 3 holes. So these 2 holes, for instance, this is, let's say, our left side. So these 2 holes are the mounting holes into the frame. And this is the stock foot peg location. So what we want to do here, and this is the same thing but for the right side. So these are not drawn to scale. These are really bad drawings in general, but it's just kind of to illustrate the point here and keep my measurements in check. So what we're going to do is we're going to take measurements from the ground to the center line of this hole, and our foot peg location. And we're going to use those to basically create the height of these things and do it in reference to the ground, because all of these measurements we want them to move relative to the ground so we can keep track of our ground clearance and all that stuff. It's not necessary to do that. You can just move this relatively speaking, but it's just something that if you can reference something in the real world that might impact your design, you should probably do it that way. And then we're going to go through, and we can do this off the bike, thankfully. We're going to measure the distances between the holes, just normal distances. So the distance between this hole and this hole, and the distance between this hole and this hole. And what that'll do is that'll allow us to locate all of these holes in 3D space. So wherever we want to do in our CAD program, we can locate these 3 holes and then use those locations to create new locations and everything else. We're really worried about locating these ones, but we do want to be able to reference our original foot peg location so we know kind of where we're going with the new design. And the idea being we'll use these measurements to create our first foot peg locator, and then we can start locating the other pieces once we have that done based on the relative reference location for the foot peg. So that's what we'll go do here. Well, all right. We got our pieces off the print here, and we've also taken off the fairings because we're probably not going to need those anymore when this thing goes full adventure bike. We're not going to run fairings basically, or any fairings we do run will be off of the roll cage. So we took those off so we can start looking at the frame, figure out where we're going to attach all of our roll cage mounts to. And we got some pretty decent ideas, I think. But that's for a different video. This video, we're talking about foot controls. And foot controls here. This is not a full foot control set, obviously. You can see we're playing around with some mounting points for the brake master cylinder, the rear brake cylinder here. But this is our foot location test fixture. So kind of when you're doing a design, you want to step it through a little bit. You want to not waste a bunch of design time building a final product unless you like the step up to that. So that's why we've gone through the way we have, starting with, hold on, let me grab it. A locating fixture like this. I actually broke this one trying to trim it to fit into the mounting locations. It's really easy and simple design. Get your locations right, get something that you want to finish, get a finished part out of, and then you can go work on something that's a little bit more complex, which is a validation fixture, which is essentially what we have here. So this is a validation fixture. It's a little bit more burly. I'll go through the design momentarily here. The idea is we put it up, it's a little bit more burly so we can put a little bit of stress on it. I couldn't stand on this, obviously. I didn't design this to be stood on. But I can actually put my feet up there, move around on the seat a little bit, and test out the fit to see if I liked it, and I do like it. And then you go into designing your final prototype fixture that you can go move around and muck around with. So that's going to be our next move in this video, but right now we're talking about this. So this fixture is a placement validation fixture. This is for the left-hand side. You'll notice it's pretty simplified, relatively speaking, to one of these. And that's because, just as we were talking earlier, you want to spend the minimum amount of time on these validation fixtures, because if you spend 20 hours, 30 hours CADing up a fixture, like something like this, that's what you think will be the final product, and you don't like it, you may have to redo 15 of those 20 hours just to get the fixture the way you like it to. Whereas if you draw simple fixtures like this one or this one, this is, 30 minutes of time to CAD this up, get it in the right location, take some measurements, and then validate that you like where it sits, and then you can take these models and create a prototype fixture to replace those. So these are two-part fixtures, mostly to save some print time and to make it a little bit easier to print, so I didn't have to use nearly as much support material. But what we have here is, and we have a plate like this plate on the back here, up to this white point here, is mounted in, and then we have a separate removable, or used to be removable, foot peg. This foot peg was supposed to be removable, but made this a little bit thicker, and it's actually too big. It's too long. This foot peg's not how it's going to sit in real life, but I just wanted something easy to find when I was just test fitting. But shoved it in here, and we added something in here that's not typical, that wouldn't made it in the final design at all. Besides these huge things being not here, this is not how big this connection is going to be. But we added this locating pin. So these foot pegs have a second pin that's located up above the first one. The idea being that I did this mostly so I could locate what I thought was vertical, relatively speaking, and put it on here and then check and see if that fit felt right. And it does pretty much feel right. And this was especially so I could locate it vertical and keep it from rotating if this fit here in this main barrel going through here was too loose to hold it in place. It turned out it wasn't, but oh well. That was trying to think a little bit ahead and what would screw me and make a 24-hour print a complete waste of time. But it worked out okay. And we have this here, which is pretty good, actually. Fits good. Location's not bad. I'm not really what I was hoping for, and what I found, getting a little sniffly here, is that my foot doesn't really impact on this exhaust manifold here, nor does it get anywhere near any of the, this is like your oil cooler lines to your radiator up there, or any of the engine case. So if we place stuff out this far, what we've actually done is given ourselves plenty of space to move around on the bike when we're up on pegs and stuff like that. So this placement is actually really good. And you can see the pretty drastic change in foot location. So we're going to shoot you about from the side as much as we can. So that's down, something like that. Pretty close. You can see that's down a few inches and forward many inches. Trying to give ourselves more knee room here. So it's actually pretty successful all around. So what we're gonna do next is take these results and try and locate everything for this right side foot control. And that means locating this brake cylinder appropriately, because this, while these mounting holes are kind of where we were thinking we might want to mount some stuff, they're actually in the way. So the way, you can see the way this thing mounts the brake master cylinder, that's these two bolts up on the top here. Those are actually set back about 1/2 inch from where the regular thing mounts here. So we'll actually go design a full-blown prototype foot peg rear set. And this is actually not a rear set anymore, but a full-blown, you know, foot control mount in CAD, print that up, and then bring it back for final check. And all right, everybody, so another few hours later, we have our true blue first prototype. This is our V1 prototype for our hand control, or for our foot controls on the right-hand side. So this is your brake side here, and it's a 3-piece prototype right now. There's still a lot of stuff that needs to go into it for the final design, but that's going to be a little bit fiddly, and I don't really think you guys will get a whole lot out of it. But here's the idea. So right now we have 3 major pieces to this. You have the major mount section here, which mounts right in here. We have our brake pedal, and this is just a, we kind of just made this up real quick to try and generally match what came off of the bike. But as you can see when we throw this on here and show you the final everything on it, we still have to make a few adjustments. And we have our stand-in pedal. This is much more like a part that we're actually going to put on here. Now we may not make our own pedal assembly here because there's a lot of fiddly bits and stuff that's really hard to make on your own. Where we can just go and buy something like a pivot pedal or something like that for BMW, and then just adapt our mount to suit that. Because one of the awesome things about making your own mount is you can really adapt to any bolt size and bolting configuration that you want to. So that's probably what we'll do here. But this is roughly the same size as a pivot pedal. This is a little bit bigger, I think, but it's roughly about the size and dimension of a pivot pedal. It's a real pedal assembly. So we're gonna go throw this on here and see how everything looks. Alright, so here we have the final, or this first prototype kind of assembled here, and on the bike. This is supposed to be somewhere up here, and you can see where this is going to be a problem, so we're going to have to adjust how this works. But that's not necessarily unexpected. So, as you can see, everything fits pretty well. This thing doesn't currently install, mostly because of these line heights. So we're gonna end up having to do some work for brake lights and things like that, and I'll show you that in a second. But as you can see, this doesn't install as it currently sits with all these lines, so we're gonna have to extend some lines and do some stuff like that. But I did check fit it, and these holes do line up with the brake holes here and here. However, if we get in closer here, you can see where I had to pull out the Dremel and Dremel out this to clear. So there's a couple issues with clearance for this right now. Well, one of those is clearance on the main body, which is here to here and here. So this part didn't clear very well here. It mostly clears now, but what happens when we clear it here is that this alignment is actually running right up against the barrel here on our brake pedal line. So it's, unless you have it somewhere down in here, in which case it's too close, at least for the brake actuation and the strength of these parts. Unless you have it somewhere down here, it actually like misaligns the plunger here for your brake cylinder, and that's not great. So we have to do some work on that, and really that can involve either taking this piece, so this is at a certain angle, so this piece that would normally hook up into here is at a certain angle. We can make it a little bit closer to straight out comparatively to the pedal, so that it actually extends out further this way. Or what we can do is we can take this and actually extend the mounts further out this way, and that should clear the cylinder here for that and allow full brake actuation. The other things to note is that we actually had to go up in here and clearance this out for clearance on the back side here of our brake cylinder. So that clearance there is not a full, it doesn't allow a full circle in here, which is fine, that's okay. But you do need to keep these sorts of things in mind, and that's why you don't want to necessarily jump straight to like a 20 or 30 hour CAD model and get this whole thing and then nothing fits. So that's why we're doing this in parts and pieces, and then we find out that these clearances we need to upgrade, but if we move this out, that clearance won't necessarily be a problem. But a lot of this material is extra anyway, so we don't necessarily need all of it here. So, but good things is this clearance is quite good in the backside here, so this thing fits really well back in here, and this design is actually really good right now. It may be worth adding some increased, more material here in this section, just to increase the strength between the two mounting points, but that's something we can add later without too much issue. The other thing to note is that this pedal assembly works pretty well, and it actually lets you have your foot out here and basically all the way away from the exhaust without really hitting it. You just put a small little exhaust shield here and you won't have to worry about it at all. This brake pedal will need a bit of work. So you can see it hits on the oil cooler water pump connection housing here, hits on that bolt. So this will have to come out a little bit and then probably come in. But this was just a first stab. This wasn't supposed to be the final brake pedal, because obviously we have to work on this location here, as well as get our motion ratios right. So this current brake pedal design maintains the stock one, and by maintaining the stock motion ratio, we maintain how the brakes feel from their stock form, so that it'll maintain approximately the same amount of pedal travel and force required to actuate the brakes the same amount. What might be worth doing is messing with this motion ratio a little bit, and in so doing, what we can do is mess with how stiff or soft the brakes feel and how much pedal travel is required to get a certain amount of brake clamping force. So that's something we can do with brake pedals to adjust how it feels off-road, because these brakes really are designed to have a lot of traction and not necessarily be super, they're not necessarily designed to be the most compliant in an off-road situation. So we'll leave the motion ratios like they are here for now, but that might be something we can revisit in the future. Now, what we are missing right now in our prototype, and what we'll have to figure out for the final solution, that's not the... So what we're missing right now for our prototype, we'll have to figure out for our final installation, is a spring mechanism to maintain this pedal where you want it to be. So we'll have to work on that somehow, whether we include like a circular spring in here, like you might find on your clutch pedal, or if we come up with some other spring resistance mechanism so that everything will stay tight so that our pedals actually feel appropriate. What we also need to figure out is brake lights. So this was our stock brake light monitor, and it was somewhere in like, it was mounted in this direction so that when the brake pedal traveled, it got this piece got pulled, and that would actuate the brake light. The problem is this sort of setup right here really doesn't allow for that kind of brake light. So we're probably gonna have to go to a pressure actuated system. Most of those actually mount on the brake caliper itself. So it replaces the banjo bolt that runs from this line. This line runs around in here, runs into a banjo bolt, which is used to attach the brake line to the caliper. So it usually replaces the banjo bolt, and then we'll have to run our electrics back over into here and all that jazz. So that's probably what we'll end up having to do because of the way these things are designed, because we don't want to keep throwing more and more stuff behind here, because this is the stuff that gets hit when it falls. So the least amount of stuff possible we have kind of showing here, the better overall we're gonna get in terms of reliability, even if we are putting remote locating some of our sensors. Luckily, this brake light is not a sensor that's necessary for the bike to run. It's just a sensor that's necessary to actuate these rear brake lights when we're turning on the brakes. So those are the two remaining outliers right now. We're not going to solve those today, but this is a very good start. We're actually pretty close to having a good design for our right side pedal, and what we'll essentially do is we'll follow the same process for that side. Now that we know that these measurements kind of work, and the other pedal, this pedal, our placement pedal, fit pretty well. So now we just have to figure out kind of the same stuff we were working on here. How to locate foot pedals where we want them to, that sort of thing. All right. Can we move this back further? Maybe? There. All right, so that's how you prototype parts using your 3D printer. This is a use. I'm only using PLA. This is stuff pretty much any 3D printer on the market. My CR10's having some issues right now, which we'll go over in another video at some point. But my CR10 can do all of this printing. Anyone's printer out there, as long as you have the volume to print it, you could be printing it on your 3D printer. And this kind of shows the benefits of having a 3D printer. You can iterate and go from a measurement fixture like this one, which is pretty simple, 20-minute cab to go do this, to a location validation fixture like this one, which validates your whole locations for your mounting points as well as your brackets and your foot locations. And this bracket actually didn't work out, which is good. So you can do this in another 20 minutes to half an hour, something like that, to locate that to a first form prototype here. This is a version 1 prototype. It's the first prototype that you want to do to kind of get an idea of if you're on the right track. And you can go through all of this in, you know, what the total printing time here is. Each of these prints were, I don't know, about 10 to 11 hours. This print was a 6-hour print. So in 2 days, you can go from having no idea where you're going to put the foot pegs to a pretty good idea of what your final form of your mount is going to look like. If you're doing this in your shop at home and trying to use traditional manufacturing methods, making these parts even out of like aluminum, very thin aluminum, something like that, just it would take forever. And if you have to go out to a machine shop, let's say you don't have a mill and a lathe and or CNC versions of those in your home, which I don't, right? I would have to go have metal parts like this made at a machine shop around here. you're looking at probably a week for your first piece, just to kind of get an idea of where you want things to go. And you're not even sure if the piece you get back is going to work for you yet. So that's one of the ways you can leverage 3D printing to help you out in your own projects. What's next for this guy? This is our what's next for our Project HyperTenere R6? We're gonna work on this for the other side. We probably won't show you that video. We'll just it's gonna be the same process. You know, run in, do some measurements, come back, check out, fit, all that sort of stuff. We're probably gonna go start looking at crash bars and crash bar locations. That's why all the bearings are off here. So we can start looking at where we wanna mount crash bars and skid plates and things like that to give our engine a little bit more protection, because this thing's not really designed to lay down on the rocks like some other engine designs out there are. So we want to give ourselves a lot more protection for our engine and our radiator, and that means we got to go do some interesting measuring. Otherwise, we'll get this thing set up. We're gonna get full-blown metal pieces here, custom made somewhere. And then get our crash protection and get some handlebars on this thing, and then we can probably take her back out on the dirt and see how much better it is, I hope. That's kind of the plan from here. So until next time, guys. I can English. So until next time, guys. Thanks for watching. My name's Andrew. This has been another Make It Break It YouTube channel. If you like this video, hit like. If you have questions, comments, concerns, if I'm horrendously missing something, please let me know in the comments down below. If you like what we're doing with this channel, we got motorsports builds, motorcycle builds, all that sort of stuff, and we take 3D printers and apply that technology to it. Definitely hit subscribe down here, or here, or wherever the subscribe button is at this point in time, and go watch some of the rest of our content, because there's a lot of good stuff in there. So thanks for watching, guys. Again, my name's Andrew. This is Make It and Break It. Until next time, we'll catch you later.